The objective of this video is to differentiate implicit functions. We first introduce what we call explicit functions. Now, explicit functions are of the form y equal to f of x, y being the dependent variable and x being the independent variable. So on one side you have got the dependent variable, on the other side you have got an expression containing only the independent variable x. As an example, y equal x2 plus x minus 1. Now, to find the derivative of this function, it's straightforward. dy over dx equal to x plus 1. We now look at what we call implicit functions. Now, these functions, in these functions, the dependent variable y is not given explicitly as a function of x. Implicit functions are of the form f(x,y) equal gxy. For example, y plus ln y equal 2x plus 1. The question is how to find the derivative dy over dx of the implicit function given here. If we try to find y in terms of x, it's going to be very difficult. So we therefore need another method to find the derivative of y with respect to x. We start by saying that the derivative of the left side equal to the derivative of the right side. Now, this is a sum of two functions, so the derivative will be equal to the sum dy over dx plus d over dx of ln y equal, the right side is also a sum of two functions, 2 plus 0. Now, on the right side, we have dy over dx, which is what we are looking for. We also have d over dx of ln y. Now, this can be considered as f of y of x, a composite function, and therefore we apply the chain rule. Then d over dx of ln y will be equal to the derivative of this with respect to y, and then dy over dx. Now we put all this together, so the right side will be dy over dx plus 1 over y dy over dx. The right side is equal to 2. Now we are looking for dy over dx, so we factor this term, dy over dx, 1 plus 1 over y equal to 2, and we end up with dy over dx is equal to 2 divided by 1 plus 1 over y. Find dy over dx given the implicit function 1 over y e to the power y minus x2 plus ln y. Okay, so the derivative of the left side is equal to the derivative of the right side. This is a function of y, and y itself is a function of x. So the derivative of this term with respect to x is, using the chain rule, d over dy of 1 over y dy over dx equal. Same thing here, it's a function of y is a function of x. So the chain rule again, d over dy e to the power y, dy over dx. Now this is a function of x, so the derivative with respect to x, it's 2x. And then the last term, it's d over dy. It's also a function of a function, ln y, dy over dx. We now continue with the differentiations of the term with respect to y. So this term will give minus 1 over y squared multiplied by dy over dx equal, this term here gives ey times dy over dx minus 2x plus this term here gives 1 over y dy over dx. We now put all terms with dy over dx on the left side. So dy over dx factored out, minus 1 over y2 minus e to the power y minus 1 over y equal to minus 2x, and dy over dx. We now put all these expressions, these rational expressions, to the same denominator. So this common denominator y2 minus 1 minus 1 square ey minus y equal negative 2x. We now have dy over dx is equal to negative 2x divided by the expression. So that will be negative 1 minus y square ey minus y divided by y square, and which gives minus 2x multiplied by the reciprocal y2 at the top minus 1 negative y2 ey negative y, and now the final expression dy over dx is equal to 2x y2 divided by y2 ey plus y plus 1, rearranging terms, simplifying, and so on. Let's solve the next example. We need to find dy over dx at the point x equal to 1, y equal to 1 for the implicit function given by y plus e to the power y equal x2. Now the derivative of the left side with respect to x is equal to the derivative with respect to x of the right side, x2. This gives dy over dx plus d over dx of the composite function ey. This is a function of y which is a function of x, so we need to use the chain rule. So dy over dx, now we use the chain rule and we say that this gives dey over dy, that gives ey, and we multiply by dy over dx equal to x, dy over dx factored out, ey equal to 2x, which gives dy over dx equal to 2x divided by 1 plus ey. Now we're given the point x equal to 1, y equal to 1. We substitute to obtain dy over dx equal 2 times 1 over 1 e to the power 1, which gives 2 to the power over 1 plus e. And this is the final answer, dy over dx at the point 1, 1.